Everyone, in this video I will explain agentic workflow in LangGraph. So agentic workflow simply means that we give access to certain tools to an LLM, and then when a user asks for an input, it will decide whether some output from a tool is required to answer the question, or it can directly answer the question. It can require output from multiple tools also, so that also gets taken care. So I will explain how this works at high level first, and then we will go through the code. So the user gives an input, and the LLM, which has access to all the tools, it will return an output. Okay, so now this conditional routing will check whether the output is a simple AI message. If it is a simple AI message, then it will directly go to end, and that will be the output to the user. But if the output coming from the LLM has a tool call, okay, then it will go to the tool node. Then that tool will be executed based on the input information provided by the LLM. So what it will tell is that which tool should be called and what should be the parameter values to be passed. Okay, so LLM will only give us an output which will tell that whether a tool should be called or not. It cannot directly call the tool itself. So this tool node is the one which will call the tool. It will generate the output from that tool, and then the output will go back to the LLM again, because if we just return the output coming from the tool, it might not look very pretty. So that output will go back to the LLM. Again, it will decide whether another tool call is required, or it is the information is sufficient to answer the question. Based on that, it will return another output. And then again, we will check whether it is a simple AI message without tool call. In that case, it will come to end. Otherwise, this can keep going till all the tool calls are completed, or till LLM decides that, okay, now I have all the information to answer the question. So this is a typical agentic workflow. Now let's go to the code to understand how this actually works. So here is a notebook. We will do all the necessary imports. We will initialize our LLM. So here I'm using Grok API because it is free. And to understand how to use Grok API in LangChain for free, please click on the link in description. Then we initialize all our tools. So I have created very simple three tools. So to make a Python function a tool, we simply add a decorator tool, which is coming from here, langchain.tools. Okay, so very simple three functions which we can call as tools: multiply, add, and divide. So this talk string is very important, which will tell that what this tool can actually do. So here it will tell perform multiplication. Here it will say perform addition of two integers, then perform division of two integers. Okay, so then we create a list of all the tools that are available, and then we create a LLM with tools out of the simple LLM that we have initialized first. Okay, so how we can do it is we can simply call this bind tools method on top of LLM. We pass all the list of tools that are available to us, and then that becomes our LLM with tools. So whenever this node is called, it will not call the basic LLM. It will always call LLM with tools, because it will have information of all the tools that are available. Okay, so this is very important. So we initialize our LLM also, and we define all our tools also. Next, we define all our nodes. So here, if you see, I haven't defined any state for my graph because we imported this message state from LangGraph, which is this. Okay, so this is nothing but this. It is simply a predefined state already present in LangGraph, which has this field, messages field, which is annotated with add messages reducer. That means that every new message that is sent in the messages field will be appended to this field rather than overwriting. Okay, and then the output will be in form of a list which has all the messages of type base message. So base message can be a human message, an AI message, a tool message. It can be anything. All comes under base message. So to simplify this, this has been replaced with a predefined class in LangGraph, which we will use directly. Okay, so here what we are doing, we are simply doing LLM tools. We are simply invoking, and then whatever messages are already present in the state, we are sending it to this LLM. So this will be called multiple times. When it is called for the first time, this state will only have the human message, which is coming from the initial state as user query, but it will keep appending all the tool messages, everything, and then the over a period of time, a complete list of all the messages will be sent to this LLM, and then it can return the final output. Okay, so every time we call this, we simply return this messages as list of response. Response can be an AI message, it can be a tool message, it can be human message, anything. Okay, so next is the tool node. Tool node also, they have simplified it by predefining a class called tool node coming from langgraph.prebuild. So what tool node actually does is this. So tool node, what it does in official documentation of LangGraph, they have defined these nodes using Python, but they have already added this as a class in as an import in LangGraph, which we can directly use it. But technically, what it does is that it will check the messages, and then if it has a tool call, then all the tools will be called using this. So we will simply create a list of messages, which was not required here, but we can simply create this list, tools by name, and then we call this name. Then that tool will be called and the output will be generated, and then we can just uh, append the output as a tool message to the messages. Okay, so this is replaced by this now. Here what we do, we simply just send the all the tools that are available to us to make this tool node. We don't have to define this function. Okay, this is also their conditional should continue type of conditional router function, which also has been replaced by this tools condition. Okay, so that I will explain once I reach here. Then I will explain what is this doing and how it is replaced by this. Okay, so now we will define our workflow. So first we initialize our state graph by sending message state only. Our two nodes. So we only have two nodes here. One is this LLM call node and then tools node. So this is the LLM call function that we have defined, and this is the predefined tool node that is already there. We simply define our nodes. Then we define the fixed edge. Fixed edge is this from tool to LLM call. This is very important because otherwise, if we connect this directly to end, then the output will not look beautiful. So that's why the final output should always come from the LLM call. Okay. So this conditional edge we have replaced with this. So earlier in the documentation, they have used something called should continue. They have defined it using Python. So what it does is that it takes the final message from the messages. Then it checks if the message has a tool call. Then it will return the tool node. Otherwise, it will end. It will return the final output to the user. Okay. So it is very simple, but they have replaced this with this tools condition router. Okay. Simply we just start from LLM call, and then we add this tools condition, and it will take care of everything automatically. The only caveat here is that uh, the tool node should always be named as tools. If we name it something else, then tools condition will not work. If we want to name it, give it a custom name, then we will have to write this function of our own, and then here we can define whatever node we can define this thing. Okay, we can name it anything we want. So that is the thing. Then again, this edges from tools from LLM to LLM. Then we compile it and we display the graph. Okay, I think I forgot to run this. Yeah, this I did not run. Now I will run this. Yeah, so it is the same graph, so this complete thing, this routing and this connection is very important. Now let's try to see few examples how this actually works. So first we will simply invoke it and see how the output looks like. So these are all the messages saved. First, the human message comes from the user input. This is the message. Then AI returns a tool call. Okay, so here it has returned two tool calls. One is add and second is multiply. These are the arguments. So since we have used pretty print, so it looks like this. But if I simply take the messages, it will look like this, the complete list of messages. And if I want to only take the final output, dot content, then this is the final content which is coming from the LLM. The result of adding 3 and 4 is 7, then multiply by 7, multiplying 7 by 2 is 14. Okay, so if we try to stream this, then we can see that what all nodes are getting executed at each step. So here you can see first there was an LLM call where the content was blank, but it involved tool calls. Okay, so this tools condition will automatically check that whether tool call is available, then it will automatically go to the tool nodes. Okay, so here the tool will be executed, and then as a tool message it will be added, and then the content we can check. So LLM will automatically check this, what is the output, and use it in the next step. Then finally LLM call where tool call is not involved and the messages, the content of the AI messages present. So in this case, this condition will be satisfied, and then the final output has returned. So this is a very simple agentic flow, but we can make very complex flows also. Please let me know in comment section what other complex scenarios you want to see around AI and around LangGraph. Please subscribe to my channel. Thank you for watching. Bye.